So here, we're going to be learning the next couple of sections about finding x-intercepts of parabolas. X-intercepts. Now here's the thing. There are several different names that we can call x-intercepts. Kind of like the vertex could be called the maximum or the minimum, the highest point, the lowest point. Just like, what's something else that has multiple names?
X and Y.
But that's multiple points. That's not what I'm looking for. Okay, so slope is also the rate of change. No matter which one I'm saying the same thing. Slope and rate of change could be that way. A semi-truck or a transfer trailer or an 18-wheeler, they're all talking about the same thing, right? Different names for the same thing. X-intercepts have several different names that we can call them by, especially when we're dealing with curved graphs, like a parabola is. No, it could be called the x-intercept. It could be called the solutions to the graph. The solutions to the quadratic function. What is the solution? It's where it crosses the x-axis. It's the same thing, okay? Nothing different. We sometimes call them the zeros. That one I rarely use, but your book may use them. A multiple choice test like the ACT may use it. Why do you think we call them the zeros? Because the y value is 0. It's where it crosses the x-axis. It could be called zeros. It could be called the roots. So roots is kind of the old school word. Like back in the day, they would have used roots the most common times. For me, you will hear me say roots and x-intercepts the most. That's the ones I use.
How in the world do we have multiple names for stuff?
It's all about their situation with how they're being used. In a lot of word problems, we call them solutions. Because you don't say, where are the x-intercepts of the golf shot? Okay, but you could call them the solutions, maybe. A lot of word problems use this. Roots is used for a lot of uglier graphs. So if it has a lot of x-intercepts, or eventually, later this chapter, you're going to be learning about imaginary numbers. And let's not go there. Roots encapsulates imaginary roots as well, where it really crosses the x-axis, or where it doesn't cross, but it kind of does. But that's not. Don't worry about that yet. Okay, this is all you need to know. These are 4 ways to say the same thing. All of them are talking about x-intercepts. That's all you really need to know. So here is a problem. It tells me to find the solutions of the quadratic equation x squared minus 16 equals 0. So eventually, not today, I'm going to show you how we could solve this algebraically to find the solutions. We're going to solve for x, right, and get x by itself. But for today, we're not going to use that strategy. We're going to use our graphing calculator today to look at the graph and figure out where the solutions are. So when they ask for the solutions, what is it they're wanting to know? Your x-intercepts. Where does the graph cross the x-axis? So let's put this equation into our graphing calculator. So what looks different here? There's no f of x. Or there's no...
Can we put the equal sign?
Nope. So let's talk about that very quickly. x squared minus 16 equals 0 is the same thing, but let's talk about this for just 1 second. If I had f of x was equal to x squared minus 16, what does f of x represent? It's y. This is just saying y. Y equals x squared minus 16. Now, what happens on an x-intercept? Think about any x-intercept you could think of. What's this point? Let's say that's 4, 0. Let's say this point is negative 3, 0.
You're increasing. I don't know.
It's a maximum.
Thinking specifically about the solutions, the roots, the x-intercepts. What's true of both of these x-intercepts?
They both touch the x.
They touch the x-axis. What else is true of both of the x-intercepts?
Their y-intercept is 0.
That's not their y-intercept.
Or their
The y value is 0.
You're touching the graph physically.
X-intercepts always have a y value of 0. No matter where my x-intercept is, its y value is always 0. Do you see that? Y value is always 0. So think about this. What did f of x represent? You told me f of x just means y. Well, where do we want the y to be?
It's 0.
0. That's what they've done here. They have plugged in 0 for y and ask you to find the x value. Where is y 0? Like normally, if we wanted to know when x is 3, what's the y value? What do? We plug in 3 for x and find y. Well, now we want to know when y is 0. So I'm plugging in 0 for y. Find the x value. Anyways, we're not going to solve it algebraically today. I'm just kind of setting you up for what we're going to be doing Thursday or Friday, whenever. Whenever.
we probably ain't gonna be doing it Thursday. I hope not.
He did not say anything.
I ain't gonna be here. Ooh.
So let's graph this. Have you graphed this yet? In our graphing calculators, let's put y equals x squared minus 16.
How do you zoom it out?
Zoom 6. That's your zoom standard.
That thing.
Zoom 6 if you need to see the whole graph. So now where does it cross the x-axis? Where are its solutions?
Negative 4,
4 and
0.
negative 4.
So negative 4, 0,
And 4, 0.
and 4, 0. Those are the solutions. Those are the roots. So again, what they're showing here, the solutions are the values that make the equation true where the y value is 0. These are where the x-intercepts occur, and they're in the same position. So solutions is another word for x-intercepts. Could also be zeros or roots. That's what they're getting at there.
Oh, and it worked.
So when we look at this one, what are the solutions to x squared minus 14x plus 49? So we're going to put this in our graphing calculator. Y equals x squared minus 14x plus 49. If you guys need help putting this in, hopefully we're getting good at this by now. We've been working at it and working at it.
Hopefully.
So when it asks you for the solutions, it's asking where does it cross the x-axis?
Oh.
Like I understood the other one. Like this one. It's not the same.
What do you mean it's not the same?
It doesn't cross.
It doesn't, it's never zero? It doesn't have an x-intercept?
Well, yeah, but it's like
It's 7 for me too.
7-0. Just 7-0.
It just starts it.
That's all.
Yeah, that's the vertex.
Okay, so what happens when the x-intercept is the vertex?
I don't know.
Well, you only have one x-intercept now.
Yeah.
Right? There's only one x-intercept.
Zang.
Okay.
So this point, it crosses, or it touches the x-axis. It doesn't actually cross it, but it touches it. But that still counts as an x-intercept.
So all you need is just one x-intercept for most problems, or what is it?
Well, the last one we looked at, there were two x-intercepts.
Yeah.
This one we're looking at, there's only one x-intercept. So again, the things they want us to make sure we talk about, the graph touches the x-axis, but it doesn't cross it. And this time there's only one x-intercept, and it's at the point 7-0. This is a special case. This only happens when the vertex is the x-intercept. All right, so we could have two x-intercepts. We could have one x-intercept. Let's find the solutions to x squared plus 3x plus 7.
Yes.
Oh my gosh, I can't even see. I don't know, maybe 4.5,
That's right. There's no.
It crosses the x-axis at 4.5.
5.5. I don't know, I can't see.
It doesn't
I don't
cross
think
it
it
anywhere.
crosses. Oh, yeah, it don't.
It helps if you plug it in right.
I don't know, I don't.
So remember, we are finding the x-intercepts. Where does this graph cross or touch the x-axis?
It don't.
It doesn't.
0.
It doesn't. It's not a 0. 0 is an x-intercept.
Nothing.
It's not a
I
0.
was making zeros, nothing.
So what are the solutions? What are the x-intercepts? It doesn't have any. It has no x-intercepts,
So is this an
so we could say it has no solutions. So when we graph a parabola, there are three possible outcomes. What are they? It could
Have two x-intercepts, one x-intercept, which is the vertex.
It could cross the x-axis twice. That looks like this, or something like that. Two x-intercepts. It could so happen that the vertex is on the x-axis. If that happens, you're going to have one x-intercept, or one solution. Or what's the third possibility? It could open up and be above the x-axis, or it could open down and be below the x-axis the whole time and never cross. This would be 0 x-intercepts, or it has no x-intercepts. So you'll put this into your graphing calculator. X squared minus 7x plus 6.
It's crazy how fast the lives go up. Like, you just scroll up, it goes from like,
Is everybody good here?
yeah.
Now let's click second
Dang it, I need to go back.
window.
Oh.
Second window to get your table set up. So we typically, like if you ever get a calculator and somebody has been a loser and they have scrolled down to negative 8,000 on the X, you don't want to scroll back up, right? I mean, that'd take forever. So what you can do is you click second window. It asks for the table start and the delta table. So the table start means, where do you want your table of values to start? 0. We like starting when the X value is 0. So we can put in a 0 there. And then the delta table, or that's the triangle, that means delta. That is, how much do you want your X's to change by every time? So like if you need to look at like a decimal, you can make your delta table 0.25. Then your X's would go 0.25, 0.5, 0.75, and 1. Typically, we like our delta table to be 1. So we go from 0 to 1 to 2 to 3. But if you need to change that, this is where you can do it. Is in this table setup. Is everybody there? Everybody follows. So we've got 0 as our table start, 1 as our delta table. Now let's click second graph to pull up our actual table of values.
What's the independent defense? You just keep that on.
Which now you can use this calculator of mine, right? Whenever you could buy your own if you wanted to. You can use Desmos if you're at home. DESMOS, Desmos, that will graph it. It has everything that this calculator does.
I saw one of these
But
on eBay.
My point is, I'm practicing so much with these calculators that I'm hoping you'll use them as a tool, and you'll use one like this on the ACT.
How much?
Where can I buy one?
Walmart, yeah, Amazon.
$800.
Yeah,
Calculator?
I saw one on eBay and it was like,
No, they're about 125.
it was probably like it's probably a set. Yeah, it's probably a set.
Might have been.
That I'll just go on there.
But like if everybody wanted to use these calculators on the ACT, every math teacher here has one. Has a set like I have. We could just go, if they're not gonna, if everybody uses my 30, I'll go get some from the other ones. We'll get as many as we need. That's my goal. That's my goal is you get so comfortable using this
I love these.
that they're the best tool for it.
I understand.
Yeah. And you can do so much stuff with it and figure out stuff you didn't know
I got a question.
just by putting it in your calculator.
What does stow mean right here?
I have no idea. I've never used that button once.
I've been trying to figure out what it means, but
Okay, so now we put it in our graphing calculator like this, and then we put up our table of values. We said we were looking for where the y value is 0. That's where it crosses the x-axis, where the y value is 0. So where is that at? It's at 1, 0, and 6, 0. So those are the x-intercepts, or the solutions, or the roots, or the zeros, right? All are saying the same thing. Any questions here about finding the x-intercepts using a table? Everybody's good there? All right. Let's do another one the same way. Find the table.
Do it algebraic. Or whatever the word is.
That's next lesson. It's not today. Next lesson. And that's the way you're gonna have to really know how to do it. It's factoring. It's factoring.
Oh.
That's what we're getting to.
I was excited.
Stuff never goes
So
away. Exciting.
What's factoring?
Like, if I wanted to really know where these x-intercepts are, I would factor it. That would be my. But then you're gonna also learn factoring doesn't always work, and we'll learn some more tools that take the place of factoring. You might like those better.
Hope that's right.
I had a question.
hate factoring.
When you're scrolling up, like the numbers like increase like very like the Y values increase very rapidly. Why does it do
I hate
that?
factoring more than I
Because
hate
it's growing
trigonometry.
exponential growth.
Oh yeah.
Because there's an exponent. It's not linear. It's exponential.
Smart.
So to get to the table, you're going to click second graph.
It's made in the
Oh,
Philippines.
what am I doing?
Once you type this in, you're going second graph to look at the table. And we want to look for where the Y value is 0.
-2.
Does everybody have this entered in their calculator? 3x squared plus 5x minus 2. 3x squared plus 5x minus 2. 3x squared
Dang it,
plus
Cheryl.
5x
$1
minus 2.
When my dad was here, we put as a basketball.
Wait, what are we?
3x squared plus 5x
I started beating my dad.
minus 2.
Okay.
I want my table set to be 0 and 1. Pull up my table. So I'm looking for where the Y values are 0.
It's only one. That's sweet, dude.
Okay? So I see there's an x-intercept at -2, 0. All right. Is that the only x-intercept?
Looks like it.
On the table, that's the only place I see y is 0.
Yeah.
You guys agree? If I look at the graph,
There's 2 plots. Yeah.
But it's decimal.
It would have to be this one. You'd have to put your tables.
so looking at the graph, how many x-intercepts do I see? 2. So-
It's like,
I don't know.
Let's go back. Let's look at the table again. Let's look at the table again. Think about what's happening here. What's happening? Look at my y values.
You're going up by 1.
The y values are going down, down,
Up.
down. Why do you think that's going up? Do y'all see what I'm saying when it's going down? Look at the y values. 48, 26,
Yeah.
10, 0. The y's are going down. Everybody follows? What's happening here? The y is going down to -4. So we're now beneath the x-axis.
Yeah.
Or where y's are negative. So if we go beneath the y-axis, and then it starts to go back up, right, from -4 to -2, if we're going up, right here, if it goes from being negative to positive, what has to happen if the graph goes from having a negative y value to a positive y value? It has to have crossed the x-axis at some point. Has to have. At some point, it had to be 0. You guys understand that? What I'm saying? So, it's somewhere between 0 and 1. That's all I know. Somewhere between 0 and 1 it happened. So, let's go to our table set. And let's start at 0, but let's go up by 0.25. Alright, pull the table back up. So now at 0.25 it was still negative. At 0.5 it has become positive.
I think.
So it's somewhere between 0.25 and 0.5. See, I'm getting a little bit more information. I'm narrowing in on where this is at. So we could go again. I could go to 0.125. I'm just cutting 0.25 in half. Now what do I know? Where's my x-intercept? Do you guys follow what I'm doing here, or do y'all don't have a clue? The y's are negative. Somewhere between here, the y's switch from negative to positives. It had to have crossed the x-axis somewhere between 0.25 and 0.375. How long do you think I can keep doing this for to try to find it?
Too long.
Forever. Okay? And you may still not find it. So, for today, we are good enough saying the second x-intercept
0 point.
is somewhere between 0.250 and 0.3750. Somewhere between there. I don't know exactly, but I know it had to have crossed.
0 point.
So,
Points of a millionth power. Trillion.
that's like when you put that in an answer, would you put that, have to put like,
I'm sure it's going to be multiple choice.
oh, okay, I was gonna say, because,
Like, 'cause I don't know how they're going to be able to tell you which ones to do. I'm sure it'll be a multiple choice answer.
okay.
God. I'm sorry.
Do you understand the logic, though?
Yeah.
How? So that's what's most important. Okay, so we want to find the solutions to 4x squared plus 3x minus 7 equals 0 using a table. Now here's a hint in this question. If you have to approximate, like we did on the last one, I said between 0.25 and 0.5. They say give the answer to the nearest tenth. So what does that mean if we're looking at tenths?
It's gonna be a decimal.
1 decimal place. A tenths place means it's 1 decimal place. So if you have to approximate, what do you want your delta table to be? How much do you want each one to increment by? 0.1. If I'm finding to the nearest tenth, I want the delta table to be 0.1. Now you may want to start with it being 1. 0 and delta table 1. Because there may be 2 x-intercepts. Right? One may be really pretty. If you go 0.1 forever, that's a lot of scrolling to find where the first one might be. I would always start with my delta table at 1 and see if I can find any. And like I said, I don't have the answer. I don't have a teacher's edition, so I'm doing it just with you guys.
Teacher's edition.
Can I go up there and put the buttons?
We'll do
are you-
random.
Okay. So you are not recording this.
You are not.
Okay, I see one of them.
Yeah, I
All
got
right,
one of them.
okay, all
But
right.
then the other one
And
is
then the
like,
other one, I understand there has to be another one because it goes down and then becomes positive. Okay, so I'm gonna go with, Yep, I got my approximation.
it's 1, 0, and then what is it, jump? Negative 1.8. No?
I forgot to change my thing.
You guys ready?
Yeah.
Pick a number, 1 through 25. 18.
Good.
Oh, there is 18.
Pick a number, 1 through 25. 1.
Alexander.
What's yours?
Oh, I'm not ready.
Okay.
I got the first one though.
Okay.
1-0, I think.
1, 0.
Yeah.
You guys think that's one of them?
That's for sure one of them.
Is this a problem that only has 1? Or does this one have 2? That's 2 because we see it goes negative back to positive.
Where's that dang thing?
Where? Can I like say it? I think it is.
So what do we need to do? Because it tells me, give it to the nearest tenth. So where does it cross over at? It's between -2 and -1. Does everybody see that? It's between -2 and -1.
What?
Everybody sees that, follows that?
Yes, if you just
Yes.
look at the graph, so,
Yep. We're trying to do it from a table, but you can't do it from a graph.
Where you know where it crosses from though, that's what
Kind of give you a little bit of a hint.
Yeah.
But on the table, you can tell too, because it goes from positive to negative.
Yeah.
If I go to second table set, so click second window, I want to start at -2 as my delta table, and because it tells me nearest tenth, I want delta table to be 0.1. That's tenths of a value.
wait, where do you want to start at?
-2, because I know it's between -2 and -1. So I just said start at -2, and then make my delta table be 0.1. Now pull the table back up, so second graph. Now where does it cross from being positive to being negative?
At like 1.8.
It's between -1.8 and -1.7. Alright, so if I have to only give one answer, which one's closer to a y value of 0? Is it -1.8 or -1.7?
1.8.
Okay, so when I look at that table, -1.8 gives me what value?
56.
0.56. -1.7 gives me what value? Negative. Which of those numbers is closer to 0? 0.54
Yeah.
is closer than 0.56. So this is closer to the correct intercept. So if I have to approximate, it's about at -1.70.
So that's the sign you put is about.
That means approximately. So I know there is a solution at 1,0, and there's approximately a solution at -1.7. Questions?
I mean, it's pretty straightforward.
I agree, as long as you know how to work it on your calculator and you understand the process. Okay, here. Anastasia hits her golf ball off the tee. The height of the golf ball is modeled by the function f of x equals -5x squared plus 25x plus 1. Which again makes sense because negative means the parabola opens down. What does a golf shot look like? It goes up and down. So it's an opens down. So again, I expected A to be negative. X is the number of seconds after the golf ball is hit. So what we want to know is how long is the golf ball in the air? So if you think about it graphically, again, we're just, as soon as y'all see words, y'all just automatically shut down on me, don't you?
Yeah, our table start, what does it mean?
If this parabola is going to open down, how long is it in the air? Well, it will be from here until it goes back and has another, hits the ground at 0. Right, until it has the next intercept. So our table start normally is 0, starts at 0, and our delta table is 1. Is our normal. So if it were me, I would put this in my graphing calculator. So I'm going to put in -5x squared plus 25x plus 1. I'm going to click table set. I'm going to start at 0. Delta table is 1. And I'm going to look at the table. I think I put something in wrong. I did.
Did you say delta table 1? Yeah.
Why does it say?
You probably hit a minus sign instead of negative as your A.
That one looks.
You have to do the top one first. They did have to do like table start and then go to the page.
So time starts at 0, right? If X is the seconds after the golf ball is hit, we want to start when X is 0. And then how long does it take for it to go back to have a Y value of 0? Well, where does it happen? It happens somewhere between 5 and 6. You guys see that? At 5, the height of the golf ball is 1 foot above the ground. 5, 1.
Yeah.
And then at 6, the golf ball would be at negative 29. So,
Big jump.
well, negative 29 would mean it's going beneath ground level.
Yeah. It's somewhere between.
So this parabola, like if you look at it graphically, you see how the golf ball goes up and it looks like it continues to drop straight down?
Yeah.
It can't, this parabola can't give context. Me and you know this golf ball doesn't go underneath the ground. Once it hits the ground, what's going to happen? It's going to change. It's going to hit the ground. If it was a drive, then it's probably going to bounce a little bit, bounce, and roll out as long as it can.
This is where it hits originally.
We're just looking how long it's in the air.
Yeah.
So it hits the ground right after 5 seconds. Because at 5 seconds, it was still 1 foot in the ground, 1 foot above the ground. Right? You see how 5, 1? It's 1 foot above the ground. So right after 5, what happens when a golf ball is 1 foot above the ground? Well, it's fixing to hit. Right? I mean, it's not going to magically jump back up. It's fixing to hit the ground. So it's just a little after 5 seconds. Now, what we can do to find exactly where it is, if we need an exact answer, is everybody ready? I'm going to show you a little hint here. Teach you something new on the calculator. We got an approximation of about 4. Let's find exactly where it is. Click second and click calculate, which is above trace. So second trace.
Bro, I could be using this all along, bro. What a jam.
If I'm looking for the x-intercept, what's another name for x-intercept?
0.
0.
I'm so glad you mentioned
So we're going to click 0.
Oh, what?
Do you see it? Everybody click 0.
What?
Let me do it again. Everybody stay with me. Click second.
Dog.
Click trace. You see, you should have this comes up that says calculate 0. I'll do it over here. That way you guys can see it. I forget that you guys are calculator.
Dumb? Yes.
But you just need a little bit of help with this. What is the equation over here?
It's negative 5x squared plus 25x plus 1.
Okay, so here I am. I've graphed it. There's the golf shot. I see it's a little after 5 seconds. But I know it's not exactly 5 because when I looked at my table of values, 0 and 1, right, it was still just barely above the ground after 5 seconds. So to find exactly where it's at, we can click second, trace, and I'm going to find the zeros, the solution, the root, the x-intercept. All mean the same thing. Alright, so what it's going to make me do is it's going to make me give kind of a guess. So it wants a left boundary. So what that means is I'm going to find a point that is just left of that x-intercept. So you see I'm clicking right?
Yeah, you can't go up and down its own.
Yeah, it's just left or right because we're moving like a timeline.
Yeah, like the
From left to
x-axis.
right. Everything that I've been trying to preach to you guys. So I'm going left to right. Pick any point that's left of the x-intercept. So it can be any point left of it. You can pick here, here, here. Doesn't matter. It just has to be left.
How are you staying on the...
I click second. I click calculate. I click 2 to be at 0.
Bro isn't listening.
Mine's going up and down.
It will not if you did everything I just told you to do.
Well, I guess I did.
Look at my up and down. Okay, look, I click enter for my left boundary. Then I'm gonna go right. I need to go right of the x-intercept, any of these points. Click enter again for a right boundary. Then it wants me to give a guess. So I'm gonna go back up to about where I think it's at. Oh, it's about 5. Right, and then it's gonna tell me exactly where it is. It's at 5.039685 seconds.
Whoa, what?
Which again could be rounded.
You lost me.
Yo, so it, would you just say 5?
I heard it.
Just say around about 5.04 seconds. It'll tell you, round to the nearest 1,000 or
Yeah.
100.
Dude, boy.
It's not quite, if you will.
Right of it, click enter again.
Go
back to yes.
I need help.
I just said 5.
Okay,
I need help.
okay, I'm gonna do it one more time up here, because you're not the only one that needs help. Alright, let's do it again. Where do you need help from? Have you got it graphed?
Yes.
Click second. Click trace. Is everybody here? We're going to 0. And I'm going to click enter. It wants me to go left. Pick a point that's left of the x-intercept. So I'm going to pick here. Is everybody okay? This is left. Click enter. Then it wants me to pick a point that's right of the x-intercept. So I'm going to pick here. Enter. Then it wants me to give a guess. So I'm going to go back to about where it's at and click enter.
Oh, okay, I got it.
Okay.
I'll forget about that.
You guys can go. You too.